Hello there, in this video I'm going to discuss with you chemistry paper 4 is 4 to May-June 2020 paper. Okay, so the time is given here 1 hour and 50 minutes. So let us continue with question number 1. Okay, the first one, give the name of the process that number 1 occur when a gas turns into liquid. So it's a condensation. Okay, number 2, occur when a solid turns into gas without first forming a liquid. This one is a sublimation. Okay, is used to separate a mixture of liquids with different boiling point like water and alcohol, right? So we will use a fractional distillation. Okay, number 4 is used to extract aluminium from aluminium oxide. So it should be under electrolysis. Okay, number 5 is used to separate a mixture of amino acid. Okay, this one is separating these molecules, so it should be more precise. It should be chromatography. Okay, next we move to the next question. Okay, question B. Question B, the symbol of the elements in period 2 of the periodic table are shown. Okay, so this is period 2. This is starting from group 1, 2, group 13, 14, 15, 16, 17, and also 18 here. Okay, for each of the following, give the symbol of an element from period 2 which match the description. Alright, so this is matching. Each element may be used once, more than once, or not at all. Alright, so which element combines with hydrogen to make ammonia? Ammonia is a formula, is nitrogen and hydrogen. Alright, this is the formula. So here will be nitrogen and makes up 21%. So this is oxygen. Okay, so oxygen. Okay, had atoms with only 2 electrons in outer shell. This one should be group 18 because this one is stable, right? So here should be an outer shell, only 2 electrons. 2 electrons. Okay, an outer shell. So this one should be group 2. Okay, group 2. Valence electron is 2. Valence electron, well, valence is 2. So it should be beryllium, Be. Has atom with, let's scroll up a bit, okay. Has atom with only 7 protons. If it's 7 protons, this is equals to 7 electrons. We change this one to electron configuration, which is 2.5. So this is a group 15. Group 15 is group 1, 2, 13, 14 and 15. So it should be nitrogen again. Okay, it's an atomic monoatomic gas. This should be inert gas. So let me scroll up a bit. Okay, this is an inert gas. Okay, so it should appear to be group 18. So 18 is neon. Okay, 18 is neon. So you should put there Ne. Soft metal stored in oil. Okay, this one is must be from group 1. It's a soft metal, is a group 1. So group 1 here we have lithium. So which is this? Lithium. Okay, so just write down the answer over here, lithium. Okay, so we have done this first question. So total is 11 marks here. Okay, let us move to the second question. Okay, fluorine is a group 17, form both ionic and covalent compound. Magnesium react with fluorine to form ionic. Yes, because magnesium is a metal. So magnesium is a 2 plus, fluorine is only 1. Then they cross multiply, you have the fluorine, magnesium fluorine 2. Electron configuration of atom. Okay, so here we have a 2.8.2 and an atom of fluorine. So here the calculation is 2.1234567, 2.7. Okay, then what is the question? The question says complete the dot and cross diagram to show electric structures. So what happens is this magnesium, okay, this magnesium they will be donate to, it will become magnesium 2 positive with the electron configuration of 2.8. So you just have to draw here one more circle. Here is 2 plus. So we just take this, draw 8 electrons over here. Okay, so it is stable, so it's 8. So okay, we have done for magnesium. Now for fluorine, this one it accepts 1 electron to become 2.8. So we have the minus 1, and we make another one more circle here, and we have dot 8 dots. Make sure you have 8 dots there. Okay, that's it, we are done. 3 marks. What's the formula of magnesium fluoride? MgF2. Okay, now here comes. So magnesium fluoride is ionic. Okay, it's an ionic bonding and does not conduct electricity when it's a solid. What can be done to solid magnesium fluoride to make it conduct electricity? Okay, the answer for the first question is we heat it. Okay, we heat it until it melts. So this one will become a molten state. Okay, it will become a molten state. Or what we can do is another options here. We can dissolve it. Okay, we can dissolve it in water. So if in water, it will become an aqueous. Okay, it's an aqueous solution. Alright, so this one is you have two choices. You can answer this or this one. You get 1 mark for this. Next, we have to explain for this one. In your answer, explain why magnesium fluoride conducts electricity when this change is made. Because, let me change the color here. Okay, because molten or aqueous state. Okay, molten or aqueous state, it has moving ions. Okay, it has moving ions that enable electrons to enable transfer of electron. Okay, you just make it that transfer of electron. So this is your another 1 more mark. Okay, so this is 1 and this is 2. So total you have 2 marks there. Okay, carbonyl fluoride is a covalent compound. It is the formula of it, and I complete the dot and cross diagram to show electron arrangement in the molecule of this. So I have explained in the previous paper that this one should be done in a Lewis structure way. Okay, so when you convert the drawing into Lewis structure, so what happened? Carbon you will have, we follow this valence electron. Fluorine you have 7, carbon you have 4. This one is valence electron. Okay, oxygen you have there 6. So what happens is you have carbon 1. I just put the X, 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 X. So when I draw here oxygen with dots, so and I draw here fluorine with 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So here we have a single bonding just like this picture, and here we have a double bonding. Okay, now I'm going to draw this. Okay, alright, so fluorine already becomes stable, it got 8 electrons, and fluorine becomes stable, got 8 electrons. Same goes to the oxygen. Now if you look at carbon, I draw it in a red color. So this is carbon. Okay, this is carbon also becomes stable. They have shared 4, so we have like a total 8 carbons there. So you see this, let me highlight in the yellow color at this part, right? Okay, over here, this part, this column, they shared 2 electrons. So what we can do here is we just have to draw only how to show. The X I draw is for the carbon. Okay, so here got 2, so I just make it in this way. Okay, so the X is for the carbon and the dot is for the others. Okay, fluorine you got 1 here, 1 shared, and here you have 2, so 1 I put, 1 is here, and then that's it for the carbon. And fluorine you have 1, 2, 3, 4, 5, 6, and same goes to here, 1, 2, 3, 4, 5, 6. For oxygen you have 1, 2, 3, 4. Okay, that's it. So we can use this picture to actually answer this question. You'll be getting here 3 marks. Okay, so I hope you understand on this. Okay, next is we are going to move to C. Okay, melting points of a magnesium fluoride and carbonyl fluoride are shown here. Okay, this is ionic. Okay, this is ionic and this is a covalent. Okay, explain using your knowledge of structure and bonding why magnesium fluoride has a high melting point. So it's 2 marks over here. So okay, so you can say it has ionic bonding. Okay, it has ionic bonding, which has the force of attraction between oppositely charged ions. Okay, and it needs a lot of energy to break the bonding. Okay, so now the keyword here is it has ionic bonding, alright, which has forces of attraction between an oppositely charged ion, and it needs a lot of energy to break the bonding. Alright. Okay, next we are going to number 2. Okay, now for the second one, explain Explain using your knowledge of the structure and bonding why carbonyl fluoride has a low melting point. Okay, let me scroll above. So they have about negative 100, 111, and here is about 1000 over. So this is a covalent bonding. So what you're going to say here is uh, carbonyl, okay, carbonyl fluoride has covalent bonding. Okay, covalent bonding which is weak. Okay, which is weak, and you can continue here due to forces of attraction. Okay, forces of attraction between molecules. So small energy is needed. Okay, small energy is needed to break their bondings. Okay, so here the keyword here is has covalent bonding which is weak due to force of attraction between the molecules. So small energy is needed to break their bonding. Okay, so here's a 2 marks. So total for the second question is 13 marks, total marks here. Okay, now we're going to the third question. Okay, now number 3 here, sulfuric acid. Sulfuric acid is made from sulfur in 4 stages. Stage 1, they converted into sulfur dioxide. So S plus with O, you have the sulfur dioxide, and the sulfur dioxide is converted into sulfur trioxide, which is this. They burn further and they become SO3. This is a reversible process, okay? And then this one converted into oleum. Oleum means they mix with already sulfuric acid to form oleum. So here we just plus H2, S3, S is 3, and O is 6. Here should be 3, so it will be getting there 7. So S is 2, okay, so 2, 2, 7, and then this oleum will further mixed up with the excess water, and you'll be getting sulfuric acid in a huge volume. Okay, so this is the entire process, and this process is called as a contact process. Okay, contact process. So number 1, how sulfur is converted into sulfur dioxide in stage 1, that I have explained over here. They are heated in the air. Heated in air. You can say that. Okay, this is 1 mark. Okay, now describe how sulfur dioxide converted into sulfur trioxide in stage 2. So you should have a equation for the reaction, which I've done in the stage 2 at this part. Temperature used and name of this catalyst. Okay, I'm going to explain it over here. Let me scroll down. Okay, so here is sulfur dioxide plus with oxygen. You will form sulfur trioxide, and then we balance this equation. You'll be getting here 2 and 2. So you got here total 4 oxygens plus with 2, and here 6, so it's balanced. Okay, temperature used is 450 degrees. Okay, 450 degrees. And the name of this catalyst used is vanadium 5 oxide. This vanadium is from the from the transition element. Okay, this is as catalyst. Is the temperature used. Okay, the reaction in stage 2 can reach equilibrium. So what is meant by the term equilibrium? Okay, so the term equilibrium here, it means forward reaction. Those equilibrium, they have this symbol. Okay, they have this symbol like a plus with b, you got the c. So a plus with b will can form c. At the same time, the c can form backward. It means it's a reversible reaction. So here the best way to write the answer is first one is rate of forward reaction, which means the a plus b equals to c. Okay, this is the forward reaction, is equals to backward reaction, or you can say it's a rate of backward reaction. It can be backward reaction or reverse reaction. Okay, reverse reaction, it means the C can go back to A and B. Alright, so this is the thing. Okay, so from here you'll be getting the 2 marks over here. Okay, so next we're going to B. Sulfur trioxide is converted into oleum. This one in stage 3. What sulfur trioxide react with to convert it into oleum? So they'll react with concentrated sulfuric acid. Concentrated sulfur, you can put a formula or you can write a name, sulfuric acid. Sulfuric acid. As I mentioned here in my equation earlier, so you look at that here at this part, number 3. Alright, number 3 at this one here. So this is the equation for it. Okay, now we'll move on further. Okay, oleum is converted into sulfuric acid. Can write the chemical equation, conversion of oleum into sulfuric acid. And we can refer back what I have write in this stage 4. They mix with water. Okay, they mix with water at this part. So we can write down this equation over here at the C. So here you'll be getting the oleum H2S2 and O7 plus with water, they'll form sulfuric acid. And then we have to balance this. So here it becomes 2. Okay, here's become 2 and you'll be getting here your 2 marks. Okay guys, so I hope you can understand this contact process. So when copper, so we're going to D, when copper is reacted to hot concentrated sulfuric acid, sulfur dioxide is formed. Balance this equation. So how do we balance this equation? Now we look at Cu, copper and copper. There is no changes. And then here is sulfur. Here's 1. Sulfur you have 2. Okay, sulfur we have 2 after this reaction, which is this and this one. So we can put here 2. So here we have 2 sulfur before the reaction, and after the reaction we have 2 sulfur. Now we have to make a balance of a hydrogen. So here we have 2, 4, total is 4. So here we make it into 4. Now we calculate the oxygen. So here we have 2, here we have 2, here we have 4. So total of the oxygen molecules is 8. So here's 2 times 4, you got 8. Yes, it's balanced. Okay, this is your D question. So we have solved it. Okay, now is E. So E, sulfur dioxide is a reducing agent. So it means it will reduce others. So give the color change that occurs when excess sulfur dioxide is bubbled into acidified aqueous potassium manganate. Okay guys, this is a purple color. Okay, whenever you have this potassium manganate, please remember you have a purple color. Right after oxidation or reduction process, they will be changed to colorless. Okay, alright, so you have 1 mark here. When sulfuric acid reacts with ammonia, the salt produces ammonium sulfate. So we can write here, they already give us the hint. So we just write here, this is for sulfuric acid plus with ammonia. Ammonia is just NH3. So this is acid, this is base. So what we are going to have here is ammonium sulfate. Okay, let's say the formula you don't know how to do. Ammonium, you have an ion of NH4 and here's plus. Sulfate is 2 negative and 4. So what happened? These 2 will move here. It will make NH4 with a bracket of 2. Alright? Because they have more than one element. And SO here 4. Alright. Now we try to balance this. Sulfate group, there's no changes. If you look at nitrate, here got 2. Okay, nitrogen got 2. So here we make it into 2. So here we have 2 nitrogens. Hydrogen here got 8. And here got 2 plus 6. Yeah, you got 8. Yes, it's balanced now. So you got that 2 marks. Okay. Barium sulfate is an insoluble salt. Can be made from aqueous ammonium sulfate using a precipitation reaction. Okay guys, anything to do with the ammonium salt, it is soluble. Okay, this is soluble because they have ammonium here. Name a solution that can be added to aqueous ammonium sulfate to produce precipitate barium sulfate. So we have to choose barium, a solution with barium salt. Okay, so barium salt. So we can choose barium nitrate because all these nitrate salt are soluble. So I just want to make a basic explanation here. So this experiment is something like you have a soluble and you have a soluble salt A and B, and then when you mix both of them, so they will have two things over here, which is the liquid and is precipitate. This is the insoluble. Okay, so here, so either one will become a soluble salt, the another one will become an insoluble salt. So but initially both of them have to be a soluble salt before. Okay, ionic equation for this precipitation reaction include the state of symbol. Okay, so you can make it like, okay, at first both of them is soluble, right? So they are in an aqueous solution. So we just put there if they are aqueous. Okay, they are aqueous, and then we plus with sulfate, which is also aqueous, and then they'll combine together to form barium sulfate. Okay, barium sulfate. So here is a solid. Okay guys, so I hope you can understand this. This is a simple synopsis of a salt chapter. So you have a 1 mark here and 2 marks here, and total we have a 16 marks. This is for question 3. Alright, so let us move on. Okay, this is question number 4. Oxygen is produced by decomposition of hydrogen peroxide. Okay, so magnesium 4-oxide is the catalyst for this reaction. Alright, so here what is meant by term catalyst? 2 marks here, so we need 2 points over here. Okay, it's a substance that you can say it's a substance that speed up reaction. Okay, speeds up reaction and remain unchanged at the end of reaction. So there's an important keywords there. It speed up reaction. Okay, it speed up reaction and remain unchanged at the end of the reaction. Okay, we move to the next question here. Okay, this is question B. A student measure a volume of hydrogen produced at regular time interval using apparatus shown. Okay, for your information, hydrogen peroxide is given by H2O2. Okay, this is a formula, molecular formula for hydrogen peroxide. A large lump of magnesium 4 are used. Alright, so here volume of the oxygen produced, this is the time. Okay, so on the question asking, let's scroll down. What happened to the rate of this reaction as time increases? In your answer, explain why the rate changes in this way. Okay, for this question, to understand the rate of reaction from this graph, right? So we have to look at this, the red line here. This is the rate of reaction. Okay, so the steepness, the gradient of it, the gradient given by, okay, this is the rate. Okay, this is the rate of reaction. So it's given by volume, which is here, this part, and over time. So if you look at this gradient here, from down to the top, it is reducing. Okay, reducing, and at last it changes to 0. Okay, so that is the changes here. So we have to explain from here A, B, and C, and D. So what happened here as the time increases? So now you could say, firstly is the rate reduces. Okay, you can say rate of reaction reduces. Okay, so this is 1 mark for you. And then we have okay, why the rate of reaction is reduced is because the particles, okay, the particles here, or you can say the reactant, okay, the reactant I would like to add up here, we can say amount, okay, amount of particles or reactant is getting lesser per unit volume. Okay, per unit volume. So I scroll a little bit up here. Okay, this is the second point here. So what happens if the amount of particles is getting lesser per unit volume? So you can say fewer collision occurs. Okay, fewer collision per unit time. Occurs. or you can say the frequency is much more lower for this one. So this is another point over here. So at the end, what happens is the reaction stops. The reaction stops because all hydrogen peroxide is used up. Okay, all hydrogen peroxide is used up because the only things to be blamed over here is hydrogen peroxide, because as you notice here, there is the factor of catalyst. You could see here the large lump of magnesium for oxide are used. So we have the catalyst a lot, but the reactant hydrogen peroxide is limited. So this is the limited factor, we call it. Okay. So now we scroll down back. Okay, so now we're having 4 marks here. So one is this: the rate of reaction reduces, amount of particles or reactants getting lesser, and a fewer collision per unit time occurs. Okay, fewer collision, and the reaction actually stops because all hydrogen peroxide are used up. So you got there 4 marks. Okay, now the experiment is repeated using the same mass of magnesium oxide. Powdered manganese oxide is used instead of lump. So this is powdered. Okay, this one is powdered, so it will be like much more effective. It will faster the reaction. Okay, it will make the reaction much more faster, and all other condition remains the same. So sketch a graph on the axis in B to show how the volume changes. So the only factor that changes here is the large lump. Okay, the large lump is being changed to powdered form. This one is being changed to powder. This is under powdered form. So what happens is it will make the reactions much more faster. So I would like to draw another graph here which has the same level. Okay, so we just make a line over here. They will not change the okay, this is the level. They will not change the volume of oxygen produced because the amount here is remaining the same. So they just faster the reaction is much more steeper and it goes to the same level. So this is the answer here for the powdered version. Okay, so the marks given here is 2 marks. So we have got it successfully. Okay, for the D, in terms of particles, explain what happened to the rate of this reaction when the temperature is increased. So here we have a 3 marks, so I'll give you like 3 points. Okay, so I'll start from here. So what happened to the particles is particles gain kinetic energy. So their movement is very in very high speed. So and they move faster. Okay, they move faster. So this is 1 mark. Okay, another point here is you will have more frequent collision occur when it's a more frequent collision occur, what happens is you can continue there, and greater probability of particles having having uh, having great having energy which is higher than activation energy. Okay, this is the key point here. Activation energy okay, so you can see the last one is when more collisions, okay, I just add on here that when more collisions is successful, the rate of reaction here will increase. Okay, will increase. Okay, for here I just want to highlight a few things here. They gain more kinetic energy and more faster and more frequent collision occur and higher probability of particles having energy higher than this activation energy. Okay, so when there is more collision are successful, the rate of reaction automatically will be increases. So these are your 3 marks. Okay, this question you have to take note because it's often come out in an IGCSE question. Alright, so next we move on with another question. Okay, for E, alright, for E here, the equation of decomposition of hydrogen peroxide is shown below, right? So here 25 centimeter cube of aqueous hydrogen peroxide forms 48 centimeter cube of oxygen at room temperature and pressure. Alright, okay, so calculate the concentration of aqueous hydrogen peroxide at the start of the experiment using the following step. Okay, so now calculate the number of moles the oxygen formed. So the volume of at room temperature here is given by 24 d metric cube. Okay, so what we can do now is, okay, remember that 24 d metric cube, when we change to centimeter cube, it will multiply with 1000, so it becomes 24,000 centimeter cube. So here we have 48. Okay, we take from this oxygen, we divide with 24,000, and we'll be getting here, 0.002 moles. Okay, 0.002 moles. Okay, this is for the oxygen is being produced. So now deduce the number of moles hydrogen peroxide. So okay, now we have to compare here. Okay, now we have here 2 hydrogen peroxide. Okay, the ratio of 2, water is 2, and your oxygen is 1. So when your oxygen is 1 is equals to 0. 0.002 here. So if 2, the ratio is 2, so here by right it's supposed to be 0.004. We just have to multiply. Okay, so here for the working we just can 0.002 to multiply with 2. So your moles of hydrogen peroxide here will be 0.004. Okay, so we already managed to get the mole here for hydrogen peroxide, and we scroll down Okay, the third one is calculate the concentration of hydrogen peroxide. So to calculate the concentration, we need mole divided by volume. Alright, so the mole we have obtained, which is 0.004 here, divided by okay, now the volume for this hydrogen peroxide they mentioned is a 25 centimeter cube. So we have to change this into dimetric cube by dividing. So 25 divided with 1000. Okay, so here when a calculation here 0.04 multiply with should be multiply with 1000 divided by 25. So here you'll be getting your answer 0.16 mole dimetric cube. So that is your answer here. Okay, so you'll be getting the 3 marks there. Okay, now let us move to the next question. Okay, now the question F. Oxygen can also be produced by decomposition of potassium chloride. Okay, this one. The only product of this decomposition are potassium chloride and also oxygen. So we can write the formula here, K chlorine, and this is a potassium chloride, and the product here will be potassium chloride plus with oxygen. Next is we just have to balance it. Okay, so how do we balance it? K is the same, Cl is the same, now this chlorine. Okay, so here we make it as a 2, so we have that 6 oxygen, and here we have 6 oxygen. So the balance we have to potassium is 2 here, here's 1, so we make it 2. Now we check for chlorine, we have 2, and here we have 2. Yes, we have already balanced this equation. Alright, so you are getting here another 2 marks. So total marks for the question number 4 is 16. Right, so I hope you can understand this. Next we are going to question number 5. Okay, number 5, electrolysis of a concentrated aqueous sodium chloride, so NaCl, using inert electrode forms chlorine, hydrogen and sodium hydroxide. Okay, this is concentrated solution. So what is mean by the term electrolysis? This is for the A. So electrolysis is a breakdown. Okay, it's a breakdown of substance. So let me just write it down here. It's a breakdown of an ionic compound. So the electrolyte should be an ionic compound to conduct electricity in a electrolysis. So it can be compound, you just put a bracket here, it can be under molten or aqueous solution. Okay, aqueous solution. Okay, breakdown by using electricity. So you can say electric energy. Okay, so this is this is the definition of it, electrolysis. So you got that 2 marks. Okay, name a substance that can be used as inert electrode. So this one we can use it as a platinum. Okay, your answer can be platinum. Platinum, or you can also say as a graphite or carbon. Okay, graphite or carbon. So inert means it's stable, they do not react with the electrolytes. Okay, now next we move on. Write the ionic half equation of formation of hydrogen during this electrolysis. Half equation here. So you will have a hydrogen cation going to anode, alright, going to anode, they'll absorb electron and they'll form hydrogen. But hydrogen do not exist as a mono atom. So what happens is they'll exist as a atom. So we just have to balance this. Everything you have to add on 2 here. Okay, so this one is another one more mark here. So give the formula of the 4 ion present in concentrated aqueous sodium chloride. So obviously we have a sodium ion, then we have a chloride ion, and then from the water, okay, from the water we will have a hydrogen and we will have a hydroxide ion. So these are the 4 ions that presented in this solution. Okay, now next one is explain how sodium hydroxide is formed during this electrolysis. Okay, how this one? Okay, at anode. Okay, you can say at anode, which is a positive charge. Chlorine. Okay, because since it is a concentrated, so they will discharge this chlorine ion. Chlorine ion will be discharged. It is charged, you can say, while at cathode. While at cathode, you will have hydrogen ion will be discharged. Okay, so the remaining sodium and hydroxide ion will react to form sodium hydroxide. Okay, sodium hydroxide. So this is the explanation how the sodium hydroxide is formed during this electrolysis. So you got that 2 marks here. So total for this 5th question is 8 marks. So now you're going to the 6th question. Okay, question number 6. Okay, propane reacts. This is alkane, yeah. So it is alkane. React with chlorine in a photochemical reaction. Okay, this reaction is actually called as a substitution. Okay, it's a substitution reaction here. 1 mark. So the condition is needed for this reaction to occur is we need the ultraviolet. Okay, or just like in short we just put UV or ultraviolet rays or light. Okay, because this ultraviolet they has a certain frequency and energy that can actually react make this reaction to happen. Okay, so we'll be getting here 1 mark. Okay, next I move on with this. Number 3, draw 2 structural isomers with this formula. So you can draw okay, C you have 3 and here we have 3 carbon, and then we can put here chlorine. Okay, we can put at the end here 1 more chlorine. So the rest will attach with hydrogen. Okay, so you just have to write it down, all hydrogen here. Okay, same goes to this one. Isomer is same formula but a different structural formula. Okay, so this is a structural. Okay, so that's it. So we have another 2 marks over here. Okay, now we move with another question. Okay, now is B. Okay, propane. Okay, so this is alkene, is different from the question before. It reacts with chlorine in an addition reaction. Why it is addition? So that's the question. State why this is an addition reaction. Because double bond breaks. Okay, double bond breaks and form and form single bond. Okay, and form single bonds. Okay, so double bond breaks and forms a single bond. So this is one mark. So I just want to explain further about this. So here they'll have a double bond at this part. So I'm not going to draw this hydrogen. And then here we have chlorine. So what happens is this double bond, right, they will break and they will form single bonds. So what happened to this chlorine here is they will be substituted, not substituted, they will be adding here at this part chlorine and chlorine. The rest all remains as a hydrogen. Okay, this is the explanation. So you can see the double bond is actually breaks into few single bondings. So this is a addition. No, it's not substitution. Okay, so we move on with the next question. Okay, so this is a question, next question here. So the structure of the reactant and the product of this reaction are shown. Okay, and this is some bond energies are shown over here. Okay, now they're asking a calculate energy change of the reaction propane and chlorine using the following step. Okay, let us view the questions first. So here they are asking to calculate the energy needed to break the bonds, calculate the energy released when the bonds are formed, and they're asking us to calculate the energy change for the reaction propane and chlorine. Okay, so remember few things before we begin the calculation. If you want to break the bonds, okay, break the bonds, you need to absorb heat. Heat absorbed. Heat is being absorbed. So it is called as an endothermic. So I just put the endo. So here, when you form the bonds, okay, you will release heat. You will release the heat. So this is called as exothermic reaction. Okay, so now we have to make sure which bond is to be calculated here. So you can see this bond we have to take into account. Okay, so chlorine, and then here there will be double bond. Look at this double bond. They will break this double bond, carbon to carbon. So here the calculation is chlorine 2 for 2. Okay, carbon and double bond carbon is 612. So this is the only bonding that is breaked over here. Okay, so with sum up this, you will be getting the 854. Okay, 854 joule. Okay, this is the endothermic. Okay, now when we look at this exothermic reaction, how many new bondings has been formed? So that is our main concern here. So you can see that, okay, the firstly is a carbon to carbon single bonding, so which is 3, 4, 7, and then you can see this part, right? It's a new bonding. So we have this two places, 1 and 2. So carbon and chlorine, they have a single bonding, and this one you have to multiply with 2. So here we have 339. So this 339 you times with 2, so you'll be getting here and sum both of this. Okay, so that is the calculation here. So 339 times with 2, you'll be getting the 678, and you plus with this one, you'll be getting 1025 joule. Okay, 1025 joule. So exothermic, so this reaction is actually exothermic, because exothermic heat is much more higher than this endothermic. Okay, so we have done these few steps over here. This calculation is for number 1. Okay, so this is breaking the bonds. So here's number 1, and here's a bond are formed, number 2. So this calculation is for number 1. So okay, so this is the calculation for this number 1, and bonds are formed. This one is the calculation for this number 2. Okay, so I hope you can understand this. So the last one is they are asking calculate the energy change for the reaction between both of them. So what happens is the energy is 854 from the first calculation that we have made. Okay, this is the first calculation, and then we minus with the bond that are formed. This is bond that are breaked. This is bond that are formed, 1025 joule. So here they'll be having the answer here will be negative 171. So here will be negative 171, which is an exothermic. Okay, so here we just write it down the answer, 1025 kilojoule, not joule, and then here's 854. Okay, so you are getting here 3 marks there. Okay, next we move on with the next question. Okay, this is C. There are 3 functioning groups in compound A. So name the homologous series of the compound. Okay, this one is alkene. We have a double bond here. If you only have OH, is alcohol. Okay, sorry for the writing here. Again, this is a carboxylic acid. Carboxylic acids. Okay, so 1, 2, 3. You got that 3 marks. Then we move on with the following. Okay, what would you observe when compound A is added to aqueous bromine? So since we have alkene, so what happened? Aqueous bromine is a brown color liquid. Okay, so the brown color liquid changes to so the brown color liquid, it will change to colorless because the bromine will be brick. Okay, remember when you have this, it's a gas form, it is in a brown color, or gas or liquid form. So it should be liquid form. It's in brown color. When they change to ion, okay, it's a colorless. So the next one is sodium carbonate. Sodium carbonate will react with carboxylic acid. Okay, so here you'll be having bubbles. You can say bubbles because due to carbon dioxide. Okay, just for information, it's due to carbon dioxide. CO2. Okay, compound A can be used in as a single monomer to produce 2 different polymers. Polymers draw a repeated unit of of the addition polymer formed by a addition. You just have to add on the same polymer. All right, so here we just copy paste this. First is carbon, double bond carbon, and we have COOH. So here will be CH2OH, and down here will be hydrogen. Okay, now we scroll down. Okay, so what happens is, so here we have hydrogen. Okay, now you can see here, this is, you're having a double bond, right? So this double bond will break and they will form. Okay, they'll form, and then we can draw another one more unit we can draw here. So they'll form a repeated version of themselves. This is, we call it as an addition. So COOH and here COOH. So you can see they'll form a repeated units. So this is 2 marks. Okay, so the next one is, what type of condensation polymer is formed from compound A? So you can say this is actually, okay, since we have a carboxylic acid here, okay, we have a carboxylic acid. So just to make an additional notes here, we have carboxylic acid, and then they also have an alcohol. Okay, they also have an alcohol, and they will form an ester. Alright, so when you have this condensation type happening, so you will have the polyester. Okay, poly is the name for this polymer. So your perfect answer here is a polyester. Okay guys, so I hope you can understand this question. So this is the question 6 with total of 16 marks over here. So we have done this. Okay, so I hope this video really helps you for your revision for your coming exam, and don't forget to subscribe this channel. Thank you very much for watching. All the best guys.